When you're adding or subtracting terms in algebra, if they have the same variable with the same exponent, they're what we call like terms. And to add like terms, you leave the variable part alone and just add the numerical coefficients at the front. For example, 2x plus 5x, they have the same variable part, so we just add 2 plus 5 at the front and leave the x alone. We have 7x. In a similar way, if you have a root expression where the root parts are exactly the same, such as 2 square root of 3 plus 5 square root of 3, we leave the root part alone, square root of 3, and just add the numbers at the front, 2 plus 5, and we end up with 7 square root of 3. Subtraction works the same way. 10x minus 6x, we would calculate 10 minus 6 and have 4x. The same thing with 10 square root of 5x minus 6 square root of 5x. We leave the root part alone and add or subtract, in this case subtract 10 minus 6 out front, and 4 square root of 5x would be our result. If we have 3x plus 4y, this is an expression that we can't simplify because those are not like terms. They have different variable parts. That means we can't combine them. In a similar way, if we have 3 square root of x plus 4 cube root of x, we have the same thing under the roots, but they're different types of roots. One is a square root and one is a cube root. So those terms we can't combine. They're different types of roots. You can only add or subtract radical expressions with like radicals, where it's the same type of root with the same thing under the root. So keeping that in mind, let's look at some problems where we have root expressions added together. Before you decide if they're like radicals or not, you need to simplify the root portions as much as you can. So looking at, for example, the square root of 20, the square root of 20 we could simplify by splitting it up into 4 times 5. Remember, you're looking for a perfect square like 4, 9, 16, 25 that is a factor of the number. And in this case, 4 goes into 20, and then the square root of 4 is 2. So our first portion here simplifies to be 2 square root of 5. Then we have plus. For the next term, we have a 2 at the front. And 45 is not a perfect square, but 9 is a perfect square that goes into 45 5 times. So we make this the square root of 9 times the square root of 5. And then the square root of 9 is 3. So that term becomes 2 times 3, or 6 square root of 5. Now these do have exactly the same root part, which means they're terms that we can combine. We'll leave the root part alone, square root of 5. We add 2 plus 6 at the front, and our solution is 8 square root of 5. Looking at our next problem, here we have the cube root of 54 minus 5 times the cube root of 16 plus the cube root of 2. So 54 is a cube root we can simplify by splitting it up into the cube root of 27 and the cube root of 2. Sometimes I've had students who look at this and split it up into 9 times 6 because they say, oh, well, 9's a perfect square. But remember, with cube roots, you're not looking for perfect squares, you're looking for perfect cubes, such as 8 or 27. And now the cube root of 27 is 3, so we have 3 cube root of 2 for that portion. For the next part, we have a minus 5 at the front. The cube root of 16, we can simplify by splitting it up into the cube root of 8 times the cube root of 2. And the cube root of 8 is 2. So negative 5 times 2, that part becomes minus 10 cube root of 2. The last part, there's nothing we can do with it. It's just the cube root of 2. I'm going to go ahead and put a 1 in front of it because it helps me think about what I'm doing in the next step. These are all like radicals. They have the same root with the same expression under the root. So all I have to do is leave that root part alone, the cube root of 2, and add those coefficients at the front. 3 minus 10 plus 1, we end up with negative 6 cube root of 2. So taking a look at our next problem here, we have the square root of 20x minus 6 square root of 16x plus square root of 45x. 20, we're trying to find a perfect square that goes into it. As in one of our previous problems, 4 is a perfect square that goes into 20. So we have the square root of 4 at the front. 20x divided by that perfect square of 4, we have the square root of 5x still left over. And then the square root of 4 is 2, giving us 2 square root of 5x. The next part, we have a minus 6. And then here, the square root of 16, we can calculate exactly. It's 4. But the x needs to stay under the root. A lot of times you have a root like the square root of 16x where part of it is something you can simplify, part you can't. Simplify the part you can't simplify stays under the root. So this term, when we multiply the 6 and the 4, is minus 24 square root of x. Our last one, 9 is a perfect square that goes into 45. So we have the square root of 9, and 45x divided by 9, we would have 5x. The square root of 9 is 3, so this last term becomes 3 square root of 5x. Now in this example, they're not all like terms because they don't have the same root part. The first one and last one both have square root of 5x, so they are like terms, but the middle one has square root of x. It's a different root, so it is not going to be added or subtracted to the others. Here we just calculate 2 plus 3, and we have 5 square root of 5x, and we leave that other term alone just the way it was, minus 24 square root of x. Looking at our next one, the fourth root of 32 plus the square root of 32. We can simplify these roots a little bit. You're not going to need to simplify fourth roots very often, but if you do, you're often going to need to use 16, or 81. 16 is 2 to the fourth, 81 is 3 to the fourth. So here, 16 goes into 32 twice. We have the fourth root of 16 times the fourth root of 2, and this would give us 2 times the fourth root of 2. For 32 as a square root, we would split it up the same way. The square root of 16 times the square root of 2. This time, however, the square root of 16 is 4. So we have 4 square root of 2. Now here, we do have the same number under the roots, but they're different types of roots. So we can't combine these terms. They're not like radicals. If you'd like to try the next problems on your own, pause the video now and resume when you're ready to see the solution. For 5 square root of 18, we would leave the 5 out front and split up 18 into 9 times 2. And the square root of 9 is 3. So that term becomes 5 times 3, or 15 square root of 2. For the square root of 50, you would split it up into the square root of 25 times the square root of 2. And the square root of 25 is 5, so it becomes 5 square root of 2. Then 15 plus 5 gives us 20 square root of 2. Looking at the next part, when we're calculating the cube root of 8y to the 5th, the cube root of 8 is exactly 2. For the cube root of y to the 5th, 3 goes into 5 once with a remainder of 2. So we'll have y to the 1st and then the cube root of y squared. Looking at the next term, the cube root of 27 is exactly 3. And then we have the same problem we did just a moment ago. The cube root of y to the 5th is y times the cube root of y squared. Here we do have exactly the same variable and root part, so we add the coefficients at the front, and the result is 5y times the cube root of y squared.